Hello and welcome to my GEO 572 photogrammetry final project. My name is Andrew Marshall, and for my project I decided to use LiDAR data in order to build a 3D representation of Topeka, Kansas. Okay, so to start getting data for my project, I simply went to the Kansas Data Access and Support Center, which has downloadable ZLAS files in order to get the appropriate LiDAR data. And so what I wanted to do was to make a 3D model of the greater downtown governmental area of Topeka, which is encompasses the Capitol building and other buildings downtown. So I get the data, the LiDAR data from this website, and I got imagery data from the Kansas GEO portal on the same website that also encompasses the greater just Topeka metro area as a whole. So once that I have the data plugged in and onto the map, you can see that there are two different versions of the LiDAR data. There is the ground data in brown and then the unassigned points in gray. And so first I generated a LAS DEM raster set to help extrude the buildings when we needed. So to do that, you go to the geoprocessing tools, type in LAS dataset to raster, and use that, and then you get something like this. Okay, so after performing that tool, you can see the DEM placed underneath the LiDAR data points, and this will help get us our building footprints later for when we need to create the 3D models. Next, what I did was take the unassigned points and use the classify LAS building tool in order to take the unassigned points and generate a set of LiDAR points that correspond with the buildings that it can recognize on the LiDAR data. Okay, now after running that tool, we end up with these red points, which represent the buildings in the area that we're focusing on here. And so next what we need to do is we need to convert this 3D scene into a 2D scene in order to obtain the building footprints that we need. And so to do that, you go to the View tab, Convert to Map. Okay, now that we've converted it to a 2D map, I changed the base map to an image to be able to compare the LAS points that we have here with the actual images of the building. So here you can see the Kansas State Capitol, and the points match up pretty well with them, along with this building here and all the other buildings around it. The points did a good job of matching up with the buildings that we have. Okay, so now, after going over those points, we have to use the LAS point statistics as raster tool in order to turn them into polygons that we can then use to make 3D footprints. And so for the LAS dataset, we use the same thing that we've been using. Just name the raster, frequent class code with a sampling value of 2. We run that, and we end up with these gray polygons right here that overlay each of the buildings. Okay, so next, in order to symbolize these better, we turn off the downtown Topeka points, and we click on the color palette, go here, show names, scroll all the way down to purples, and load the symbology that way in order for it to be better easily seen. Okay, finally, we need to take what still is technically raster points and turn them officially into polygons by using the raster to polygon tool. So we input the raster data, give it a name, and run the tool, which gives us something like this in brown. Now looking at the polygon file that we just created, you can see some of the very small polygons here that have been triggered by some sort of tree or other points or interference with the actual set. So when we click on it, we see the shape area of 24 square meters, not very big at all. And so in order to weed those out, we can go to Select Layer by Attribute, input the buildings, go where Shape Area is greater than or equal to, and we'll do something like 75. And that way this will get rid of all of the small buildings that we don't need to include. Now this one seems to still be popping up, which is an area of 76. So we can go back in, select, and just modify our expression here in order to get the noticeable buildings out. Now, as you can see, some of the bigger buildings have holes in the polygon. Noticeable here, here, and on most of the big buildings. In order to get rid of those, we use the Eliminate Polygon Part tool. And so we use the feature class, name the new one, give it to eliminate anything below 50 square meters in area, and we should get a cleaner view of the polygons for the buildings. Finally, we use the Regularize Building Footprint tool in order to clean up the edges around the buildings. Now, in order to make our 3D buildings, we have to copy and paste the 2D map into the 3D scene here. Once we have the building footprints onto our 3D scene, as you can see, the DEM is more easily seen here once I turn the building points off. We use the LAS Building Multipatch tool, which will then generate our 3D buildings. And so for the LAS dataset, we use the same one. For input features, we use the footprints. For the rooftop, we use the red points that were seen earlier as our building points. We use the downtown DEM and a tolerance of 0.5 meters. Now, once we have that done, I went in and changed the color from the default white. You can see we have a 3D model of the governmental downtown area of Topeka. And now one final thing that we have here is you see some of the buildings are slightly floating. This is due to the 3D buildings using the imagery you see here, the base map as the ground, instead of the DEM that we created. And then finally, to fix that floating appearance, you add the DEM that we created as an elevation source, which then eliminates the floating appearance for some of the buildings. And so yeah, to sum it all up, this was me being able to take LiDAR data from the Kansas Data Science website, turning it into a DEM, filtering out LAS data points, making raster building footprints, and then turning it into a 3D model of the inner downtown of Topeka, Kansas. And that's it for my final project. Thank you for listening.